Alright, go ahead. Good morning. Let's go ahead and continue to look at radicals and variables. This is still on the simplifying square roots, the front page. So I can see right here that I'm automatically going to have a perfect square, and I know that 2 and 3 are prime numbers. So let's multiply this underneath one radical. So I'm going to write the square root, and I have 3 times 2 times y times y. I have a perfect pair or perfect square right here. So I'm going to take one of those out, say y times the square root of 3 times 2. 3 times 2 equals 6. I know that it's not a perfect square, so my solution is y times the square root of 6. Let's go ahead and look at f. F is the square root of 20r times the square root of 5r cubed. So when I have a pair, I know that I'm going to have an even number of things. So let's say 20 times 5 times r cubed. If I expand this to find my pairs, I'm going to say 4 times 5 times 5 times r. Oh, that's it. So I have r cubed represented by 3 r's, and then that r. I have a 4 times 5 times 5. Let's go ahead and circle our pairs, or circle the perfect squares. Now I circled 4. Even though it's not a pair, I know it's a perfect square of 2 times 2. Now, if necessary, you can expand it further so that you can see all the pairs. So I have all of these sets are perfect squares. So I'm going to take the square root of 2 times 2, which is 2. The square root of 5 times 5, which is 25, which is 5. The square root of r squared is r, and the square root of r squared is r. This is now the product of these. The product means multiplication. So I say 2 times 5 times r equals 10r squared. That is my solution. Alright, let's go ahead and look at some more examples. Alright, so radicals and variables. We are going to specifically look at variables in this case. So remember, you're going to expand to find the perfect squares, or take the square root of perfect squares, which is the same thing. If I look at g, square root of 10 times the square root of 9, x to the 10 times 9. I already know that this right here is a square root. So when I'm simplifying, I can say that that's a 3. I already know that an exponent of 10, if I divide it by 2, will give me 5. So I know that that's x to the 5th. I'm going to have 5 pairs of x's. This right here is my solution. Let's expand it for those of you who still need to see it. I'm going to have 5 pairs of x's. So 1, 2, 3, 4, 5. And I'm I'm going to have a pair of 3's from the 9. Remember, I take out 1, so for the pair of 3's, I took out a 3. For each pair of x's, I took out an x to the first. So that means when I took the square root, I had x times x times x times x times x, which gave me x to the 5th. So that's where that came from. Let's look at h. 2 times the square root of 8t squared times the square root of 5t. In this case, we are going to isolate the square roots. So the 2 is going to come out, and then I'm going to multiply what's underneath the square root. I'm going to find the perfect square in 8, so it's 2 times 4. We're going to bring the 5, because I want to write all the numbers ahead, and then I'm going to take all the t's and I'm going to expand them. I'm going to find my pairs, or my perfect squares. I have a pair here, and I have a perfect square here. Still bringing down the 2, we're going to simplify by taking out the perfect square for the variable and the numbers. The square root of 4 is 2. The square root of t squared is t. I'm going to rewrite my radical with whatever is left over. So I'm going to have 2 times 5 times t. I'm going to continue to simplify, but in this case I can now multiply what's here. So I have 2 times 2 times t equals 4t. I have what's underneath my square root. 2 times 5 times t is 10t. I cannot take the square root of anything underneath that. This parentheses indicates multiplication. So the product of 4t times the square root of 10t is going to be 4t times the square root of 10t. Go ahead and look at I. Now, for the number 80, I want to take out the perfect square, because it's underneath the square root, so I want to see what's underneath it. I'm going to leave the negative c out here. I'm going to make my parentheses, square root, so I'm going to expand the 80. I know that 16 times 5 equals 80. (16) is a perfect square, so that's what I'm going to take the square root of. So I have negative c parentheses, the square root of 16 is going to be 4 times the square root of whatever's left over, which is 5. Order of operations means that this is a product, so if I multiply a negative variable times a number, they just go together by multiplication. So you're going to have negative 4c. There's nothing to multiply this by, or nothing it can be combined with, times the square root of 5. look at j. J is negative the square root of 2b multiplied by 3 times the square root of 2b. This is a very complex problem, but what I do notice is that the square root of 2b is the same thing as the square root of 2b. So whenever you multiply two square roots that look exactly the same, you're going to have what's underneath it. So it's almost like they cancel each other out, so I'm just going to be left with 2b. So let's rearrange all this. Negative times 3 times the square root of 2b times the square root of 2b. I want to make sure I have everything accounted for. As we discussed, whenever I have the square root of the exact same thing multiplied by itself, they cancel out and give me what's underneath. So I know this for sure is 2b. So negative 1 times 3, this is still multiplication, is going to be negative 3. I'm going to go ahead and distribute. Negative 3 times 2b is negative 6b. K, it's the same thing with whatever the square root is. When they're the same, they're going to cancel out and just give me what's underneath. These coefficients right here will just be multiplied by themselves. So let's rearrange this. We have 8 times 9 times the square root of m times the square root of m times the square root of m to the 5th. We don't have to use parentheses. For me, it's easier. 8 times 9 is 72. Square root of m times the square root of m is m. So then whatever I have left over is m to the 5th, which I'm going to expand. I'm going to take out every set that I have. I have 2 pairs. So I'm going to keep on working. 72m times the square root of m squared is m. The square root of second m squared is m times the square root of m. Keep on working. 72m times m squared times the square root of m. So 72, bring that down. I have m to the first power, m to the second, so I get m to the third. And then this is left on its own, times the square root of m. This is a very complicated problem, but this whole thing is a solution.